The protocol called Routing Information Protocol, RIP, is what we are going to learn. Routing Information Protocol. See, the purpose of routing protocol, is to distribute the routes. Understand it very well. We cannot go to every single router writing routes when the network is big. We spoke about the difficulty of writing a static route in a large environment in the previous classes. So we need the support of a protocol to write it for us. For that, the protocols need to exchange the information so that one router will know about the network that is connected to another router. Yeah, they need to exchange the information. They need to exchange the route information, the network that they have. For example, I have a router 1. You see, router 2 will learn about 1.1.1.1 because R1 is informing this information. And R2 will advertise both 1111 as well as 10 network to R3. That is how router 2 knows about. Likewise, router 1 will learn about 20 network because R2 will inform. To do this distribution, to do this route information sharing, we have various protocols we discussed in the previous class. In that, first protocol is RIP. See, distributing the route information, every routing protocol does. But along with that routing information, what do they additionally inform, advertise? That you need to see. If you see that, you will know the difference between one protocol and the other. RIP advertises hop count along with route. Whereas the other protocols, they don't advertise hop count, they advertise like bandwidth or delay or cost. See, that's how the protocol vary from one another. Along with the network, what do they advertise? See, for example, if you ask me, you went to Tanzania, how are the people there? My version will be like this. Oh, the people are very sweet. They are very innocent. They are not exposed to the outside world. They are doing their best with what they have. That's what I will say. My perspective is with respect to their good side, good character. But there are some people, whenever you ask something to them, they always will try to say the first thing, the drawbacks of that thing that you ask. How is the water? Oh, the water is fully contaminated. Every time, they will speak only in negative. The water is contaminated, the water is too chill, the water is muddy. But the other person will say, the petrol is very good there. The country has got good petrol. So what I'm trying to say here is every routing protocol advertises network. But what do they advertise regarding the network differs from one protocol to another. If you like the way that RIP advertises, you go with RIP. If you like the information that are shared along with the network, what OSPF does, you go with OSPF. What do they share along with the network is what differs from one protocol to another. We call that as metric. For example, when router 1 advertises this 1111 network, it will say, for me it is 0 hop. Whoever is receiving my advertisement, for them it is 2 hop. So, for me it is 0 hop. Whoever receives this, for them it is 1 hop. So what router 2 will know that if I go this direction, I'll reach 1111 in just 1 hop away via E0 interface. Because the advertisement was coming in this direction. So I had to go this direction, E0 direction. 1 hop only. If I go, I will. 1 hop means 1 jump. 1 router is 1 hop. If I go 1 hop, I will meet Mr. 1.1.1.1. Okay, next. Now router 2 will say, for me it is 1 hop. Whoever receives my advertisement in this direction, for them it is 2 hop. 2 hops. So now router 2 will show you in the routing table that this 1.1.1.1 is 2 jump away. See, it shows how many and in what direction. How many in what direction. How many is distance. Direction is vector. So RIP comes under a category called distance vector. RIP is a distance vector protocol, routing protocol. See, based on what they advertise, they have a name. For example, OSPF advertises link state information, so it is a link state routing protocol. OSPF advertises link state information, so it's a link state routing protocol. The one who plays music is a musician. One who plays drums is also a musician, but he is also called as a drummer. And the one who sings is a singer. Based on what they advertise, they get the name. If someone is teaching, then he is a teacher. Okay. For RIP, the name is distance vector. What type of protocol is RIP? Is it a link state routing protocol? No. It's not advertising link status. It is a distance vector protocol. The reason is, along with every prefix, it advertises the hop count and the interface via that destination can be reached. Router 3 says I need to go 2 hop away via E0 interface to reach 1.1.1.1. The direction and the distance. That's why it is distance vector routing protocol. You see, in Cisco, for RIP there is a weightage given, and that weightage is called as administrative distance. Administrative distance. Every protocol has got the the preference level, weightage level. For RIP, Cisco has given weightage of 120. That's the administrative distance of RIP. What is this used for? What is this value used for? I'll tell you. If I ask, you want ruby, you want gold, you want silver, or you want platinum, which one you want? You can say any one. If I ask you, then you may say my first preference is this. The second preference is maybe platinum. Third is gold. And fourth is silver. What does that mean? You like ruby more than other three. But if ruby is not present, you like to have platinum, not the gold or silver. If these both are not present, then I will give you what? Gold. Because I don't have the first preference, your first preference. I don't have platinum, it is all given. All I have is gold and silver, but in that whichever I will give you, I will not give you silver because that's not your high weightage. Gold is your high weightage. What do you understand from this? Smaller the number, more the weightage. Smaller the number, more the weightage. My first preference is ruby, which means what? Small is bigger in this context. My first preference is ruby. Likewise, you know what is ruby? Ruby is one stone. It's been red in color. Red diamond. Likewise, every protocol has got a preference value. That preference value is called as administrative distance. Lower is preferred. For example, I'll compare with OSPF. For OSPF, it is 110. RIP is 120. OSPF is 110. So, RIP is giving the route. OSPF is also giving route. Which one router will follow? OSPF. OSPF. After I fast, if you ask me what will you eat, biryani or plain kanji, I'll say plain kanji because I am coming from fasting. I cannot eat biryani. My tummy won't accept. My preference value for plain kanji is 1, biryani is 10. Please give me plain kanji. That is the meaning. Lower is preferred. RIP's administrative distance is 120. So if a router is given route to reach some destination by OSPF and RIP, router will ignore RIP and it will take plain kanji. Sorry, OSPF. Because OSPF has got small value. Did you understand the term administrative distance?
Yes, sir.
So, lower is preferred. Small number is preferred. For EIGRP, which is our next protocol, later we'll be learning another protocol, that is only 90. EIGRP is only 90. OSPF is 110. EIGRP is 90. RIP is 120. If all these three are giving root, which one will be the preferred one? EIGRP. Right. So all three are giving root. Like I said, plain kanji will also fill my tummy. Biryani will also fill my tummy. Which one I prefer? Plain kanji. If I prefer plain kanji, can I also have biryani? Not possible. Only one tummy, man. Only one tummy I have. I cannot have two varieties after fasting. Likewise. If router prefers to follow EIGRP given route for reaching 1111, it will ignore OSPF given route and RIP given route, because EIGRP has got smaller administrative distance. So RIP is a distance vector routing protocol. RIP's metric is hop count, and RIP's administrative distance is 120. RIP's metric is hop count. RIP comes under distance vector type. RIP's administrative distance is 120. Now, RIP has got a limitation. Infinite metric. RIP's infinite metric, meaning what's the maximum metric? Hop count. Hop count is the metric. How many hops from where the RIP can be learned, RIP routes can be learned? It is only 15. So 16 is an infinite hop. 16 hop. To understand, I'll tell you. From the 16th kilometer, if someone shouts, I can't hear. I can hear shouting from my 1 kilometer to 15 kilometer. If someone is in the 16th kilometer and shout at me, I can't hear. Meaning what? My infinite metric is 16. Finite or reachable metric is only 15. That's the meaning of infinite metric. Infinite metric 16 means the reachable metric is only 15. The routes that are coming from 15 hop away, I'll find that in my routing table. But the route that is advertised by the 16th router will not be seen in my routing table, because the limitation is 0 to 15 hops. 16 is not an acceptable distance. So if the network is having this size, like less than 15 hops, then you can go with this routing protocol RIP. Yeah. RIP's metric is hop count, and the limitation is 16. Why is it like that? Why is the limitation set? Why not 25 hop support? Why it is only limited to 15 hops? See, RIP is very old protocol. In those days, we were not having that big networks in first place. Secondly, the summarization, we'll be learning concept called summarization and then subnetting, no, classless. Those things were slowly growing. Mostly, people were struggling to do basic subnetting, having classless. A lot of issues they were facing in summarization. So loops were very common because of the bad configuration that they do due to the lack of their knowledge on those days. If loop happens, the loop will come to an end very quick if it is less hops. For example, a loop has occurred. Let's say there is one connection like this. This one is saying 2 hop. And the update comes here and this says for me it is 2 hop, for you it is 3 hop. And this guy says for you it is 4 hop. What if R2 learns that and say 5 hop? And then this will say 6 hop. This will say 7 hop. Then 8 hop. 9, 10. So if it is 15, it will come to an end. One fine day, this guy will say, hey, for me it is 15. So for you it is 16. And this guy will say, I will not take the update. When you don't take the update, then loop stops. So because of the poor design, this is possible. Nowadays, you don't have this poor design, bad design. But in those days of RIP, even today, if people are not properly summarizing, this is possible. There is something called split horizon. We'll talk about that later. When you disable split horizon and then when you have improper summarization, even now the loop will come. To prevent loop, we need to have some inbuilt mechanism. That's why RIP is limited to 15 hops. 16 is an infinite metric. Now, this protocol RIP will advertise whatever they have in the routing table. Periodically, the updates are sent every 30 seconds. We call it as periodic update. Updates are sent every 30 seconds. As I said, router 1 will advertise this every 30 seconds. Router 2 will advertise this every 30 seconds. So that the other router will know that it is still valid. The routes are still valid. Every 30 seconds the update should come. If update don't come, after some time if update stops, how long the route will be hold in the routing table? It's 180 seconds. The learned route, the routes that are learned earlier will be on hold in the routing table, hoping that any moment the route will come, the update will come. It will hold the root for 180 seconds. After waiting 180 seconds, it will advertise the root with the infinite metric called route poisoning. We'll deal with those things in next class. But what I'm saying is, even after 180 seconds, it only concludes as possibly down, but it won't remove the root. It won't remove the root from the routing table. Removing the route will happen only at the 240th second. Flush interval. That is FL. This is FLU. Flush interval. Removing the root from the routing table. After waiting 180 seconds, it simply decides the root has gone down, but to remove it takes another 60 seconds. After that, it removes the root and it tries to find another route if available. So these are the timers in RIP. Updates are sent every 30 seconds. Hold time. If the update is not coming, after learning, if the updates are not coming, how long I'll be holding the root in my routing table is 180 seconds. And after 180 seconds, I'll again wait for another 60 seconds, which is totally 240 seconds. And then only I'll flush it out. All right. So these are all the timers. Okay. What is next? There are two versions in RIP. One, the version 1 is class full, meaning you should not go with this version if you have subnetted a network. If it is class full, okay. If it is classless, no. So for classless, you have version 2. The other difference is every 30 seconds to send the update, this will use broadcast address. Broadcast address 255, 255, 255, 255. This is the address to which the updates are sent. This is layer 3 broadcast address, global broadcast address. Version 2 will send the update to a multicast address. This is multicast address. We'll talk about these differences in much detail in our next class. But these are the variations that you need to know about version 1 and version 2. The other things are same, both timers are same, both are both are distance vector protocol, both have got that hop count limit as 0 to 15, 16 is the infinite. All those things are same. Both advertises the hop count. The difference is this don't advertise the subnetted prefix length. That's why it is classful, whereas this advertises prefix length. What is prefix length? Subnet mask. You remember we learned variable and subnet mask. That length, that slash 16, slash 23, blah, 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 blah. All subnetted masks. RIP version 1 don't advertise, RIP version 2 does it. Did you understand all that I said?
Yes, sir.
Any question?
So far, no, sir. We'll have to go through the recording later.